discover an ingenious, cost-free technique that has preserved wooden structures for over 3 centuries, rendering them impervious to decay, insect infestation, and the need for upkeep, all without relying on chemicals, artificial sealants, or any purchased resources. Architects in 18th century Japan stumbled upon this method, realizing that treating a timber plank prior to its installation would ensure its longevity, outlasting not only its surrounding components, but even its creators. Despite the enduring testaments of these remarkable edifices, the contemporary Western construction sector has, for the past 100 years, promoted materials necessitating replacement every 15 years. So, what profound knowledge did those 18th century artisans possess that eludes us today? And how can we harness this ancient practice to dramatically extend the lifespan of our timber? Let us delve into the details. To grasp the origins of this innovation, we must first understand the challenges faced by traditional Japanese dwellings. By the 17th century, Edo, the city destined to become Tokyo, was one of the most densely populated metropolises globally. Its urban fabric was an intricate network of wooden townhouses, merchant warehouses, and densely packed residential areas, all constructed from timber, situated in close proximity, and perpetually vulnerable. During the 260 years of the Edo period, the city experienced numerous conflagrations. These events were so frequent and devastating that residents coined a name for them: the Flowers of Edo. In such an environment, a home's fire resistance was the crucial determinant between retaining one's possessions and losing everything to a neighbor's culinary mishap. As is often the case, those at the lower echelons of society bore the brunt of the risk. While the affluent could afford stone and plaster constructions, the merchant class lacked such resources. Their only recourse was to build with wood, placing them perpetually on the precipice of ruin from a single errant spark. However, over 300 years ago, a novel approach emerged to mitigate the spread of fires across entire districts. A widely circulated narrative attributes the discovery of this solution not to architects, but to fishermen. Along the coastal hamlets bordering the Seto Inland Sea in Hiroshima Prefecture, shipbuilders observed a peculiar phenomenon with planks that had undergone partial incineration in dockside fires. These particular planks exhibited remarkable resistance to saltwater and effectively repelled the marine borers that typically bored through wooden structures within a few years. Furthermore, they demonstrated enhanced structural integrity when exposed to flames. Consequently, the fishermen began intentionally charring their timber before its use. This practice eventually migrated inland, where local builders adapted it to protect structures from a different yet equally relentless adversary: the subtropical humidity prevalent along the inland sea coast, which caused untreated wood to rot from the exterior inward. The technique they developed came to be known as yakisugi, derived from the Japanese terms for burnt and cedar. These artisans, without the aid of modern laboratories or academic publications, intuitively understood that the judicious application of heat could transform wood into a material fundamentally altered from its original state. The exceptional protective qualities of yakisugi stem from transformations occurring at the molecular level. Wood is primarily composed of 3 organic constituents: cellulose, hemicellulose, and lignin. Cellulose and hemicellulose are carbohydrate chains, essentially complex sugars and starches. In essence, they represent a food source readily consumed by fungi, mold, and termites. They also serve as fuel for fire itself, as the very compounds responsible for decay are also flammable. Lignin, conversely, acts as the structural adhesive binding the wood fibers together, possessing significantly greater resilience than the other two components. When the surface of a timber plank is subjected to intense, controlled heat, the cellulose and hemicellulose in the outer layer break down without compromising the integrity of the underlying structural core. This process, known as pyrolysis, involves controlled combustion that degrades the surface without its complete consumption. The result is a layer of nearly pure carbon, approximately 1/8 to 1/4 of an inch thick, which is chemically inert. Envision this charred layer as a protective shield. Carbon does not rot, termites cannot penetrate it, and fungi find no sustenance. Moreover, water infiltration is drastically minimized as the wood's surface pores contract and harden under the heat, forming a hydrophobic barrier that reduces moisture absorption by an estimated 80 to 90% compared to untreated lumber. Naturally, having already been depleted of its volatile fuel compounds, the surface exhibits a substantially higher ignition point than raw wood, thereby retarding fire propagation rather than accelerating it. The traditional method for achieving this transformation is elegantly straightforward. 3 cedar planks are secured together with wire, forming a triangular chimney. Kindling is then ignited at the base, and the triangular configuration creates a natural updraft, directing the flame upward with considerable velocity and concentrating the heat uniformly across the interior surfaces of all 3 boards simultaneously. The burning duration typically ranges from 60 seconds to 5 minutes, contingent upon the desired depth of char. Upon achieving the requisite level of carbonization, the planks are unbound and immediately doused with water to arrest the thermal reaction. Subsequently, they are dried, optionally brushed to accentuate the wood grain, and finished with a natural oil application to seal the surface. The outcome is a building material that achieves what no chemical treatment can. It eradicates the very elements that lead to wood's deterioration. The efficacy of this system is vividly demonstrated by structures still standing in Japan today. One such example is the Saga Torimoto district near Kyoto, a historically preserved area dating back to the Edo period. The charred cedar siding on its oldest edifices has endured for nearly 400 years. It has weathered to a subtle gray patina, yet the wood beneath remains sound, its structural integrity unimpaired. In Nara Prefecture, the Horyuji Temple complex, originally established in the early 7th century, features sections of its wooden exterior that exhibit the characteristic longevity of carbonized timber, having survived multiple subsequent fires over the ensuing centuries with minimal damage. These are not replacements. They are the original materials still performing their intended function. When contrasted with the offerings of the Western market, the disparity in performance is striking. Studies comparing yakisugi to contemporary alternatives reveal remarkable differences. The documented estimated service life for authentic yakisugi spans 80 to 100 years with minimal intervention. In regions characterized by persistent humidity and fluctuating seasonal temperatures, timber treated with CCA, chromated copper arsenate, the prevalent chemical pressure treatment in the West, typically offers a residential service life of 15 to 25 years before replacement is generally advised. From a financial standpoint, over a 50-year period, authentic yakisugi, priced at $8 to $14 per square foot, proves more economical in total cost than standard cedar siding, which necessitates professional restaining every 5 to 7 years at an expense of $2,000 to $5,000 per application, culminating in a complete replacement at the 50-year mark. Thus, given that Japan developed a method for treating wood that is not only superior but also more economical and longer lasting, why has this technique not been embraced by the Western construction industry? The explanation traces back to 1933, when an Indian chemist named Santi Kamsan patented a wood preservation process known as chromated copper arsenate, or CCA. This formulation involved impregnating timber with a solution of copper, chromium, and arsenic under high pressure within a sealed cylinder. The copper served as a fungicide, the arsenic as an insecticide, and the chromium acted as a fixative, anchoring both compounds within the wood. This process was highly effective and, crucially, amenable to industrial-scale production, enabling its widespread manufacture, certification, and sale in vast quantities. By the 1950s, the American Wood Preservers Institute and affiliated trade organizations successfully advocated for the incorporation of CCA into national building codes throughout the United States. These codes defined approved wood preservation methods based on chemical composition, specifically the types of compounds pressure impregnated into the timber and their respective concentrations. Essentially, building regulations were drafted to accommodate chemical treatments heavily influenced by industry interests. Consequently, yakisugi, not fitting this framework, was excluded. The replacement cycle that resulted was not an unintended consequence. It was the very objective. A building material that endures for 100 years without maintenance represents a single transaction for material suppliers. A material that deteriorates within 15 years, however, generates revenue for 4 or 5 replacements. The American wood preservation industry was structured around treatment facilities, retailers, and retreatment services, cultivating a market that reached approximately $3.17 billion in 2026. Furthermore, chemically treated wood carries an often unrecognized substantial cost. CCA-treated lumber contains arsenic compounds, constituting roughly 20% of its formulation by weight. Studies have indicated that soil beneath CCA-treated decks can accumulate arsenic at levels 10 to 20 times higher than normal background concentrations. Research cited by environmental health organizations has found that children playing daily on CCA-treated playground equipment could be exposed to arsenic levels significantly exceeding EPA drinking water standards. In Florida, numerous playgrounds were closed due to this specific concern. In 2003, the EPA and the lumber industry mutually agreed to discontinue the use of CCA for most residential applications, including playground equipment, decks, and fencing. However, it continues to be the standard for industrial and agricultural uses. The regulatory framework established around chemical treatment remains largely unchanged. If you wish to opt for the natural alternative of yakisugi over chemically treated lumber for your own home or project, it is certainly feasible. However, there are several key considerations. Firstly, yakisugi can be procured from specialized lumber yards, eliminating the necessity for on-site fabrication if you prefer. When purchasing, note that in Western parlance, yakisugi is often referred to as sugi ban. While not the precise terminology, it is a commonly used designation. Authentic yakisugi products are also available through specialized importers. with Nakamoto Forestry being a prominent North American distributor of traditionally manufactured yakisugi. Anticipate a cost of approximately $8 to $15 per square foot, comparable to premium cedar or fiber cement siding. While this may seem substantial, the long-term economic advantage lies not in the initial purchase price, but in the decades of avoided maintenance expenses. For smaller endeavors, or if you intend to produce it yourself, the traditional triangular flue method is achievable with basic fire safety apparatus and timber dried to a moisture content between 10 and 15%. Western red cedar is the most readily available species, exhibiting a grain structure and natural rot resistance comparable to traditional Japanese cedar. Move the flame uniformly across the surface until a consistent carbon layer is formed. For the most durable finish, look for the characteristic alligator skin texture, a deep crackle pattern indicative of adequate char depth. Quench immediately with water, allow to dry completely, and then apply a coat of linseed or tung oil to seal the surface. For exterior cladding in modern building envelopes, install the material over furring strips to create a 1/2 inch to 3/4 inch air gap between the charred surface and the weather barrier behind it. This facilitates airflow and drying of the backside of the board, preventing moisture entrapment that can cause issues in tightly sealed contemporary walls. Utilize stainless steel fasteners, pre-drilled, as the charred surface can be somewhat brittle at the edges. Presently, a resurgence of interest is underway, spearheaded by Terunobu Fujimori, a Japanese architect. His work has catalyzed a new movement in yakisugi, inspiring numerous modern constructions to adopt this age-old technique. Applications range from garden pavilions to entire residences and even commercial structures. However, bureaucratic hurdles may present the most significant obstacle to its implementation in your locale. Due to the absence of a standardized performance classification for surface carbonized timber in Western building codes, you may need to collaborate with your local building department to secure approval for a yakisugi exterior on a permitted project. Yakisugi is a process born from 3 cedar planks, a piece of wire, and the precise observation that fire, when applied with control, eliminates the sole factors contributing to wood's impermanence. Much of what this channel explores was nearly lost, not due to its ineffectiveness, but because the industry prioritized more profitable alternatives. If these subjects resonate with you, subscribing and sharing are the most straightforward ways to ensure their continued discovery. And if you are interested in learning how one individual transformed a collection of decaying wood into a free backyard power generation system capable of supplying his home, car, and garden, that video is available next.